All right, only one more example to get through here. So just like last time, let's go ahead, let's enter this equation into our calculator. So I'm going to go ahead, go back into my y equals, clear out what you had from before. Let's go ahead, let's enter in x to the fourth minus 3x squared plus 5x. I'm going to go ahead, I'm going to start in zoom 6 one more time, see how much of my graph I can see. Looks like I have a little more x max and x min than I need, so if you want to shorten that up, you can go ahead and do that. Not necessary, but it'll just make it a little bigger on your screen. I'm going to go ahead, I'm going to look for increasing and decreasing intervals. Right now with the highlighter, I'm going to go ahead, I'm going to highlight my decreasing intervals. Looks like from left to right, I'm going down here, and that's it. My increasing interval, I'm going to highlight here in the yellow. All right, looks like I'm going up everywhere there. So what I really need to note is this turning point where I changed from decreasing to increasing. That's a relative minimum compared to everything else around it. So I'm going to go ahead, I'm going to calculate a minimum. First thing it asks me is left bound. I know I'm a little off the screen. If you prefer to actually bring that y min down just a little bit more so you can really see the bottom of the graph, you can do that. Not necessary if you're okay with where it was at before. But again, minimum. Taking my calculator just a little bit to the left. So I'm going to go left bound of that relative minimum. Actually, this is an absolute minimum. It's the lowest the graph goes. Go right, hit enter again, and I'm going to see that that turning point occurs at about negative 1.5, what was that? 2, comma, negative 9.19. All right, which means that my increasing interval is occurring from that x value, negative 1.52 to infinity. That's there in the yellow. And my decreasing interval is occurring from negative infinity all up to that x value, my turning point, negative 1.52. All right. Let's check out the end behavior of the graph. Again, that's as x goes to infinity and x goes to negative infinity. What's occurring? Well, if I look at my graph, as x goes out to infinity, it looks like my y's are going up. So as x goes to infinity, y also goes to infinity. My new notation for that is going to be using limits. So the limit as x approaches infinity of my equation, this is a y equals equation, so of this graph, y, as x approaches infinity, y also approaches infinity. Here again, as x approaches negative infinity, my y's also approach positive infinity. So as x approaches infinity, y approaches infinity. Our new notation will look like this. The limit as x travels to y, or as x approaches, as x approaches negative infinity, y is going to approach positive infinity. When I glance at this graph, it appears that I only have 1, 2 real zeros, which are my x-intercepts. However, according to the degree, it looks like I'm going to have 4 total zeros. There's a possibility that the 2 other zeros are complex. There's also a possibility that it could have multiplicity. So I'm just going to make a little note of that. We're going to talk about that later in the week. But at this point, you're all set to do some in-class practice tomorrow with your partner, and we will work through some of this together on Thursday. See you then.